To begin with, it's been a it's been a bad week. Wednesday, my computer had a lot of troubles, and my video wouldn't work, Blender wouldn't work, and so forth. So I wanted to go into computer science. You should know where the updates are. So let me come down here. See if I can remember where it's at this morning. Come down here and I updates. And you see where there's a check for updates, Windows Update settings. If I choose Windows Update settings, this is where you can go to check for updates, to install them, and so forth. Um, View update history. Maybe. There it goes. And this will give you an idea of when things were installed and so forth. I don't really understand these dates, so I had to wrap my mind around that. Um, because the update that was pushed out that broke my computer from Microsoft was on 9/10. Um, and because when I came in 9/11, I couldn't do a lot of stuff, and told me to update the video driver. I tried to go do that, and they said no, you need to do a special one that came with the manufacturer, and then I went to I went to the Lenovo app that they put on here and used that to update it. Still didn't work, and then finally I got thinking it worked yesterday, didn't work this morning. What's changed? A lot of times when you're trying to debug a problem, whether it's programming or computer based, you have to think about things like that. And I thought, well, nothing's changed. My video had blown up the day before on Tuesday in a computer workshop that I held. But I didn't think much about that. But then my original thought was maybe I corrupted some files. That's a possibility. But then I remembered that Microsoft has broke me before. So I went out and looked, and sure enough, there'd been some updates. I tried to uninstall the updates on 9/11, and that fixed me. But then it changed the date on this to saying successfully installed on 9/11. So I don't understand that part. Um, anyway, I thought I'd point that out. If you need to uninstall updates, you click uninstall updates here. This will come up here. You can click this installed on date here, and it'll show you the latest ones that's been updated here. I think I finally got my automatic updates shut off now. I thought they were shut off, but the Lenovo app that's on this did its own updates. So it's what Lenovo through Microsoft is what broke me. Um, so yeah, if you ever have something break, come here, click it, click the uninstall, or you can right click on it and uninstall. I think the first time I had that happen, I was I was at home and I'd been using the internet the day before, and the next day couldn't access the internet at all, no matter what. And dug into it as much as I could because I couldn't get the internet to research it, and couldn't figure it out. Went to work, Googled what would cause it, and then I saw something about an update. Check your updates. And so I went back, and sure enough, there was an update that's been pushed out by Microsoft that broke my internet. Now I'm halfway knowledgeable. I wouldn't say I'm an expert, but I'm halfway knowledgeable on the computer. And, I was able to get it fixed. But how many people across the entire country had to take their computer into Best Buy or the computer repair shop? A lot. If you told me 100,000 people had to take their computers in to get them fixed because Microsoft pushed out this bad update, then wouldn't surprise me. I'm sure at Best Buy and places like that were very happy because all they had to do was come here, click uninstall, and maybe shut off updates, and then charge a person $100, and they probably made a killing. Okay, well, let's take a look at Invitation to Computer Science, Chapter 5. We're not going to look at this entire piece because I really do want to spend most of the time focusing on JavaScript, get you into programming. We'll also look at a little bit CSS. If you zip it up and upload it, then it will do it. Yeah, I'll show you how. I thought I replied to everybody that you weren't the only one, but I must have missed you. I apologize about that. Because I had copied my response and pasted it in, like 5 or 6 people emailed me. Because when you tried to upload that, it told you it was a security risk, right, and blocked you. How bizarre. I assumed it was CSS that was causing the problem, so it was a hyperlink. Huh. Yeah, I'll go do it now. Okay, so I got some different files here. If you got all of your files in a directory, so if I go back to documents here, so if you got all your files in a directory, you right click on it and you say send to compressed folder. Where's send to? There it is. Send to compressed zip folder. After you do that, it'll take all those files, it'll put them into a compressed file for upload purposes. And you can give it a different name if you want. If you like that name, you just press enter, and that's the file you upload. Now, usually I do it at folder level. Let me try it at the file level. So let's say I got these I'll highlight them. I click the first one, I held down my shift key, and then I click the last one, and it'll select everything in between. Now let me right click on it and say send the compressed folder. And then press enter. So if you got all of your files in one folder, then that's the way you can choose just certain ones. Mm-hmm. And that'll probably work on most of your computers. If you've installed 7-zip, if you've installed WinZip, if you've installed any other package for that, when you choose these and you do a right click, you probably won't see the send to compressed zip folder. You'll see something about send to 7-zip or send to WinZip, or you might see 7-zip compress. It'll say all different, but it's the same principle. Now, if you want to get a compression package in a along with a lot of other utilities, this is the best one out there, in my opinion. Everybody going into computer science should have this on their flash drive. It's called pzip. Now you can install this. See the portable one here? You can install it on your flash drive, so you can run it anytime you want. Going into computer science, I learned this last year. I'd have people upload all kinds of strange formats. They'd be on their Macs and they'd zip it up, and they'd be on Windows, zip it up. So I get all kinds of weird compression. And if you got some of these formats that you on Mac, you can't uncompress them on Windows without some kind of utility. And WinZip, I hate with a passion. I don't know what 7-zip. I don't think I've ever used that. But WinZip, what it does is it uninstalls your compressed folders. It things like gives you a trial, and when your trial's up, you can buy the package. Um, well, I installed it, and my trial came up, and I thought I'm not going to buy the package. I really just did it because a student uploaded a weird format I didn't know how to deal with, and I uninstalled it. It did not put back my compressed folders. And I thought that's great. It broke my default compressed folders, and when I uninstalled it, it didn't put it back. So they left a very bad taste in my mouth. And I'm not sure if I ever did get the compressed folders fully back on that machine. There is a way to restore it versus creating a new user ID. But anyway, PZip. I have it on my flash drive. Does that work pretty good? Okay. Yeah, PZip, you don't have to have admin rights or anything. You can run it right off your flash drive. And I'm not going to go into all the features of it, but you can extract, you can add it to a zip file or a compressed folders, so forth. So lots of different things you can do with it. I never have read about that secure delete. Okay. Chapter 5, Computer Systems Organization. We're going to talk about the von Neumann architecture. Talk about some memory aspects, and not going to go into a whole lot of detail on the hardware side. Um, Discuss in detail the von Neumann architecture at the bottom there. And going into computer science, you should generally have an idea of what the von Neumann architecture is. It's a term you see thrown out a lot. It doesn't help you in programming, but it's just a general knowledge thing you should know. The von Neumann architecture is the foundation for nearly all modern computers. The four major subsystems of the von Neumann architecture is a memory, input-output, arithmetic logic unit, ALU, the control unit. Now, the ALU and control unit are often bundled inside the central processing unit, CPU. Here's a diagram of it. So you get your memory, control unit, ALU, and input and output. Memory, functional unit where data is stored or retrieved. A lot of people don't understand the different types of memory. I've had people tell me that their computer has one terabyte. I ask them how much RAM they have. Then they'll tell me like, "Oh, I have 1 terabyte." What are they telling me? Yeah, massive sticks of memory. Yeah, yeah. They're telling us. Yeah, the storage on. They're telling us the hard drive, aren't they? They just don't understand the difference between RAM and their hard drive. So, and not saying if you don't understand, that's why I'm covering this because you should understand that if you're going to computer science. RAM stands for random access memory, and this is kind of a. I like to think of it as a more of a dynamic um, location, such that when you go and write a variable, it's putting it into RAM, and so you can get it back pretty fast. Kind of the sense of it. It's organized into cells, each given a unique address. Um, it's a hex address, so forth. So when you declare a variable, which we haven't talked about yet, when you declare a variable, it'll go and assign a unique address in RAM to store that. if you put too many variables in your RAM, and you'd be hard pressed to exceed the limits of the RAM nowadays for variables, but you could. Then that causes an issue. So, equal time to access any cell, and cell values may be read and changed. Now you got read-only memory ROM type of RAM with pre-recorded information that cannot be modified or changed. You typically it's your memory is 8 bits. Now I'm still wrapping my mind around this myself because they talk about when you talk about the error correction codes, like when you're passing. We talked about the voltage, I think, in here last time, ones and zeros. And you got your ninth bit, that handles the even or odd parity and so forth. Um, I don't know where that ninth bit goes. I don't know if it consumes the next set of 8 or if it'll break it up into chunks. So, and maximum memory size, address space 2 to the in power in is linked to the address. Yeah, this gives you a breakdown. Random access memory. You really don't need to know a whole lot about the details of that unless you're going into computer engineering, Wichita State. Then you probably want to read this chapter very closely. Let's see. So we got a fetch, retrieve from memory, non-destructive fetch, store, write to memory, um, memory access time, time required to fetch, store, memory address register, MAR, holds memory address to access, memory data register, MDR, receives data from fetch and holds data to be stored. If you ask me next week what does MDR stand for, I couldn't tell you. That isn't one of the important ones. What I'm trying to emphasize there is just there's a lot of definitions and so forth that aren't important. So don't think that everything in bold here you need to memorize. I'll tell you the important ones for somebody going into computer science. Computer engineering is a different matter. I never majored in computer engineering. Couldn't tell you. Got decoder, controller. Again, you don't really hear about that very much. If you're going to introduction to digital design, then we get into this in more detail, so you don't have to worry about that. RAM speeds increase more slowly than CPU speeds. You ever hear of cache memory? It's fast but expensive, built into the CPU for fast access times. I'm not really that big into hardware, but if you really that's your goal going to computer science, people that buy computers, people that build their own computers, they look at cache memory for that reason. Principal locality, values close to recently accessed memory are more likely to be accessed. Load neighbors in the cache and keep recent values there. Cache hit rate, percentage of times values are found in cache. You see these in performance tools where it's telling you how your computer's doing. I've seen that before in terms of the hit rate. Input output, keyboards, DVDs and so forth, flash drives, network. RAM is volatile memory. What that means, and that's an important term, gone without power. So if you shut off your computer, where's RAM? Gone. Yeah. So it's temporary, like a temporary place. When you're running a computer program, you're declaring your variables, and it's allocating space in the RAM for that, so you can get it back fast. But you don't need to store it. Now, mass storage systems, non-volatile memory. You got your direct access storage devices, sequential access storage devices. What would be you think an example of one memory that stays there when you shut off your computer? Hard drive, yeah. And that's what falls under the DASDs. Disks, hard drives, optical media. Um, is hard drive permanent? No. Why isn't it permanent? What? Yeah, exactly. I mean, that's exactly it. Um, it's weird to think of, but and I couldn't describe the hardware aspect of it, but they basically wear out. They start losing sectors, and has anybody had to redo their hard drive because it had like bad sectors in it, or oh yeah, it's a different. That's yeah. But yeah, they started getting bad parts spots in them because they have a lifespan. Floppy disks, if you ever remember floppy disks, they had a lifespan. Um, they weren't supposed to last past so many years. So, yeah, all that's still temporary. It's kind of permanent because you shut off your power and it's still there. But to be honest, I haven't. Yeah, that's what I'm wondering about solid state. Because to be honest, I've never read about that. Does it have a limited lifespan, or I'm assuming so. Yeah, yeah, yeah. So it's right. And I'm sure they have a lifespan. All electronics at some point fail. Um, yeah, or outmoded. Yeah, yeah, yeah. The BTK, the serial killer in Wichita. He went to his church and was working on the computer there and saved the floppy, and it yeah recorded off because when you save information, a lot of the programs will save details about if you signed in, may save that. May save detail about what's on the hard drive. Hard drive. So yeah, that's one of the biggest. Yeah, weird individual. The hard drives, optical media have tracks, concentric rings around the disk surface, sectors, fixed size segments of tracks, unit of retrieval. That's where you get like bad sectors. Time to retrieve data based on seek time, latency, transfer time. Then there's, like you say, solid state drives and other ones. And that gives you a picture, um, and it shows the rotating disk. So it's sitting there rotating around. Um, to be honest, I would think that this would have a longer lifespan than the SSDs. That's probably wrong. Um, but it seems like when you got a platter or something, it's less likely to lose it than an electronic chip of some sort. Um, orders of magnitude slower than RAM, microseconds to milliseconds. You wouldn't want all of your variables to be stored out in a hard drive and you'd have to retrieve it all the time. Um, I/O controller manages data transfer with slow I/O devices, freeing processor to do the work. So it goes off there and says, "Hey, go out there and get my data," and the processor then can continue on. And so this is acting separately, and then sends an interrupt signal to the processor when it's done. So it says, "Processor, hey, I got your data for you." And that gives you a picture of how that works. ALU is part of the processor. Contains circuits for arithmetic, addition, subtraction, multiplication, division. Contains circuits for comparison, logic, equality, and or not. Contains registers. High-speed dedicated memory connected circuits. You got your RAM that's fairly fast. You can write to it and retrieve from it. But then you got registers, which is even faster. So if you end up taking assembly language programming in the spring, you'll learn how to work with registers, and that's how you can get some very fast performance. Um, yeah, that's not an important one. Here we got a register coming in from both sides here, and then it's doing whatever processing, and then writing it back out to another register. I can't say for every hardware device, but typically there's not a register called A, B, and C. That's just indicating any one. Here's how you refer to them: R0, R1, R2, up through R15. Now, how about if I have 20 numbers? What do you think I'm going to do? See, that's the tricky part, right? Because registers are limited, and you can't even use all 16 registers. There's only certain ones you can use. I forget how many there are exactly, but there may be like 10 registers perhaps you can only use. The other ones are for specific purposes. So yeah, you have to do clever things. Maybe you start out back at 0. Maybe you swap it in and out of RAM. But again, that random access gives you that fast performance, or the register gives you fast performance. Sorry. I'm not going to go into that. You can read about multiplexers and so forth. Stored program characteristic. Programs are encoded in binary and stored in computer's memory. And control unit fetches instructions from the memory, decodes them, and executes them. You ever hear of machine language? Binary strings encode instructions. Instructions can be carried out by hardware. Sequences of instructions encode algorithms. Machine language is a language that the machine understands. When you're programming in Java and so forth, that's not machine language. That's a language so you can understand. When we're programming in JavaScript, that's a language you can understand. That's not how the computer talks. So the compiler or interpreter, depending upon what programming language you're looking at, handles that. Used to be that when you compiled a program, that it would create an executable. You could only run it on that particular hardware. For example, if I wrote a visual, I'm trying to think of an example. Used to be if I wrote a Visual Basic program, for example, and created an executable, could I take that over to a Mac? No. It was putting it into the language that the Microsoft would understand. And then even more than that, you had some issues with different architectures. Though I think they've ironed that out. Um, Anybody know what the beauty of Java is? Flexibility in terms of, yeah, kind of like that. When you write a Java program, it does not put it into a form that only one architecture can understand. It puts it into kind of like a intermediate file, and then everybody has to have the Java libraries on their PC, so that if I write a program in Java, I can run it on a Mac, I can run it on a Windows, I can run it on Linux, I can run it on anything under the sun that runs that has that Java library on it. There's a Java runtime. Like if I go, that's not what I wanted. I wanted to show all the different ones available. I didn't want it to recognize what I had. Well, if I could get to the screen, oops, here it is. See all Java downloads. Windows, Mac OS X, Linux, and you'll see out here it's specifically 10.7.3 version and above for the Macs, but you can go out and find older versions. Solaris. I really thought there'd be more than that out there. So in theory, if I'm running a Solaris machine architecture, then I can run a Java program you created over in Windows. If you created the Java program over in Mac, I could run it on Solaris. This was the problem because when you had all these different architectures, whether it's a 64-bit or 32-bit or let's see, I'm not sure if I see 32-bit. But anyway, if you had whatever architecture it run on. So that was the beauty of Java. I wonder, because that's weird that the 32-bit wasn't listed there. Um, hmm, yeah, yeah, 64 is the standard. So yeah, maybe they're stopped supporting it. I don't know. If I, in theory, I had a little mainframe, assuming there was a Java runtime on it, I could run that Java program on that mainframe. So again, that's the idea on your phone. If your Android has the Java runtime capability on it, you can run a Java program on it. If you had an iPhone, if it has the Java library on there, the runtime, you can run that Java program. So I think I showed you Dice.com where Java was like the number one sought after one. A lot of people like it for that reason. You write the program one time and you can run it on anything, no matter what your customer is using. Anyway, enough about machine language. Notice here, each kind of processor has a different instruction set, speaks a different language. There's and just generally, you shouldn't have this memorized and so forth, but you're going to hear about RISC, reduced instruction set computer, and then a complex construction set computer, CISC. I don't hear about this one as much, but you hear people talk about RISC. and they're talking about a smaller instruction sets, each instruction highly optimized, easy to design hardware. If you're here's an example. Um, Here's a reduced instruction set computer is a computer that uses a central process unit that implements a processor design principle of simplified instructions. To date, RISC is the most efficient CPU architecture technology. What we focus on, what Wichita State focuses on, is the ARM processor. When I teach the assembly language, it's focused on the ARM processor. Um, to be honest, I'm trying to draw a blank on what CISC processors would be. Um, I guess that's why I haven't worked on any of those. These don't seem familiar. X86 does. But yeah, you'll hear about the RISC in computer science. Uh, Instruction set examples, data transfer, move data from memory to register, arithmetic, like adding, comparison, comparing two values, and then branching. There's a bunch of different branches available in assembly language. Uh, Program counter. You hear about that? That's a special register that holds address to the next instruction. So when you're running a computer program and it's going line by line, this is what tells it to do the next instruction. Now, one line of your Java program or JavaScript program may actually be 3 or 4 assembly language. So there may be multiple assembly language instructions to go with that one line of code. Your instruction register, IR, holds encoding of current instruction. As one's not as important. You hear about the program counter. By the way, you're never supposed to change a program counter. So in programming, if you change a program counter, you alter the flow of your program ungracefully. So I'm gonna go. I'm gonna go shut the door. Now, when I get up, now, now when I get up, I'm right here, right? Um, where to go to now? Move that way like 10 feet or so, right? That's what your program doesn't when it's running in registers and in that high processing, it doesn't know where to go. So that's what that program counter does. It tells it next where to go. So program counter would tell me move over to this spot. Program counter then would tell me to move back to here. So does that make sense what the program counter is? Again, it tells kind of like direction. the computer's the stupidest thing ever. So it stands up and says, okay, I don't know what to do. And the program counter says, okay, do this next. And then it says, okay, I'll move over to here. And then it says, okay, I don't know what to do. I don't know how to get to the door from here. It says, okay, move over there next. So program counter is kind of the main control piece when you're running a program. Putting together the pieces, von Neumann architecture, combine previous pieces, von Neumann machine with your fetch, decode, execute phase. Fetch phase is you get the next instruction in memory, decode, instruction decoder gets opcode, execute phase, different for each instruction. I'm glancing over this pretty fast because unless you're going to computer engineering, you don't need to worry about this. If you're going to be a computer programmer, this is really a lot of it handled in the background for you. Of course, there's other non-von Neumann architectures. Problems to solve are always larger. Computer chip speeds no longer increase exponentially. Reducing size puts gates closer together faster. Speed of light pertains to signals through wire. Cannot put gates much closer together. Heat production increases too fast, so there's some issues there. Von Neumann bottleneck, inability of sequential machines to handle larger numbers or larger problems. They talk about the graph of processor speeds there. Other ways to organize computers. Most are experimental, theoretical, except parallel processing. You ever hear parallel processing? That's a term you hear in computer science. Many processing units operating at the same time. In the past, they're called supercomputers. Now you got desktop multi-core machines and the cloud. In the future, they say quantum computing. Parallel processing, isn't that what core does? Yeah. So it's where it's not like a single, they work in parallel. So if you had 8 core, you'd have eight of them working in parallel, right? Which in theory then would work faster. Yeah. You go to Walmart now. How many check if you want to actually pay cash or not go through do the work yourself where you scan it? How many registers are usually open? 6. Where do you go? Is that what it is in Wellington? I go to the one in right. Yeah, so that's not parallel. That's sequential. And so I hate machines replacing people. I love technology, but I hate machines replacing people. So I always stand that long line and I wait forever. I know I dread going to Walmart for that reason. That's sequential. Parallel is if they had 10 lines open. Then you could go to any line and it's super quick. Yeah. So that's kind of the big thing now. You hear all about multi-core machines, dual core. Yeah. So more cores better. You can almost think of it in that term. Oh, do they have a 10 core? Nine. Yeah. See, then you got your processing that'll occur much quicker. I don't know what that does in terms of graphics, like video editing. I'm assuming it probably helps, but um, yeah. 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 Usually your lower end of whatever piece you're looking at will determine what you're going to get. This I have no clue. I haven't really done much or any reading on quantum computing, so I couldn't tell. I couldn't tell you about that. Now, let's see. They actually have a type of programming for parallel processing because if you write just a normal like Visual Basic, um, it's not going to truly get the benefit of having your dual core and quad core. It has to be written with a certain languages that would take advantage of that. Uh huh. Um, and your wife's with the state fair, so you're not related to the state fair at all. Okay, then I'll show that in a second. Those are two different questions. Whether you're, um, yeah, yeah, I'll show. I think I remember how to do it. It's been a while since I did it. Yeah, yeah. Used to be you could just do a save as. It would save the entire web page onto your hard drive, or not the entire web page, the entire yeah the entire web page, not the entire site. Let me see. Okay, nothing real exciting about there. Oh, Kansas State Fair. Uh huh. Oh, really? Not on sale. Oh well. Where are we at? Tickets? Well, I'll show it with this page here. Assuming you'll let me do it. If I right click on it and do a save as, now this is an ASPX, which is probably why I wouldn't let you do it, but we'll see. Oh, yeah, it'd be better to do a save as. So if I, right. So like if I go to documents here, web page, And State Fair. Okay, so see it says web page complete down here. If you do the drop down, there says HTML only. The complete should download all images too. So if I click that option, but this is an ASPX, so it may not work. We'll see. And I can't tell if it's on there. It is show in folder. I right clicked on it and chose show in folder. Now see how it has the files here, which is everything. CSS files, cookies, JPEGs. Then if I were to right click on this and choose open with, might come in cleaner with WordPad, but I'll choose Notepad. See what it looks like. Okay, that's not good. This is it's still coming in. I figured it was all to the right. So now I have this open here. Maybe that'd be easier. What am I searching for? Okay, so Control F. Boy, this is slow. It's got 2,000 lines. Yeah. Maybe I won't wait. We'll wait for it then. But I could go in and make changes. Be nice if I don't know. There, finally. Sign up for email updates from Kansas State Fair. Sign up for there it is. Sign up to get infected. Okay, so I'll save that. Close out, maybe. There it goes. And come here. Now I'm going to right click on that and choose open with Google Chrome. Assuming I changed it in the right place. Yeah, oh no, there it is. Let's get it infected. Now, if I had a little bit better utility that would save this file, save the web page, then when I saved it, it would look exactly like State Fair, except for maybe I made a change. So how's this used? Scam people. It doesn't update the website, but I could upload it to a fake site. And yeah, you send them these emails saying, "Hey, you've been compromised. Here's the link to the site." And when they bring it up, it looks exactly like the regular site, except for the button that says login is actually running a PHP or ASPX code on their site. And so when you enter in your account information, it's storing that off, and it may redirect you to the real site. So it may just like, oh, this looks okay, and yeah, you're getting their information. So this is how they do it. Like I said, there's better tools for capturing the entire web page than this, because this doesn't look like the original page, does it? Kind of does. Some of this does down here, but I don't know what in the world this is about. Um, but again, I'm not a hacker. They have better tools to capture an entire page. So anyway, if you wondered how in the world they do that, that's the gist of it. Scary, yeah, because yeah, if this had been a page other than ASPX, I guess I don't have the page up anymore. But if this had been a page other than ASPX, it would have looked, exactly like that. So usually it does a pretty good job of saving all the files. Okay. Now I'm going to well, maybe I can get to the break. I just worry about doing 3 hours of video and having it crash again. Because I'm not going to spend much time on this. This is a tutorial for graphic design with CSS. I'm not going to have any assignment out of this. This is more just an informational type of topic here. There'll be a test over that one chapter we just covered in the PowerPoint. So you read the chapter and then you'll take the test. And then I'll give you an assignment over JavaScript, which will be the last half of class. What this particular tutorial shows you how to do: create a figure box, add a background image, add a border to an element, create rounded borders, create a graphic border, create a text shadow. And I'm not going to go into the real details here. Create a box shadow, create linear and radial gradients. Everybody know what a gradient is? That's where you go from one color to another color. Like I start over in this side of whatever as white, and over this side is dark red. So while it goes over, it goes from white to pink to light red to dark red. So it's a transition. How about opacity? What's an opacity? Yeah, exactly. Transparent, see through. Those are exactly right. So if you're trying to make something opaque, how do you say the word opaque? Well, change the opacity of it. Then you can come here and see how to do that. So there's a lot of cool stuff here. Apply a 2D and 3D transformation, apply a CSS filter, create an image map. What's an image map? Um, it's how they're set up on the page. I've designed a web page, let's say. What in the world's this? I don't want to buy it. I just wanted to view it. Oh, go away. Okay. So I got a map here, and this image is on a web page. And maybe instructions down here say click the state to go to that state's page. So if I click Montana up here, it'll go to the Montana page. It'll bring up montana.html. If I click Wyoming, it'll bring up wyoming.html. So image maps, one type of image map is where you can define that if they click anywhere in this border right here, it's going to go to the Wyoming page. You can see creating a figure box. I have to get pictures here. I'd have to go to the ebook. No picture of that. They do get a picture of background image. See they said tiled image in the back browser window. That's our background. So you have your main page here, but you have some kind of background over here. So if you're trying to achieve that, then you can get some pretty neat effects, as you can see from here. You don't have to have it tiled. That's an option when using CSS. We had you have to be careful if you don't do tiled though. Tiled is a good option. At IFR, we use this concept. We didn't use we used HTML to do it, but we had our logo. So our logo was a background, and then we had our page in the front. What do you think happened with a fixed width logo when somebody with a huge monitor looked at it? It'd been nice if it done that, even though it wouldn't look so. But what it did is it repeated the logo. So in HTML, it tiled it automatically. So if you had your logo here, then you also had it here. So like for Kali, if we had the Kali Tiger here, you'd have the Kali Tiger right there and Kali Tiger right there, and you're sitting there, oh my God, what have they done? That was one of the first things I fixed about our webpage when I took it over. Yeah, you have to be careful in terms of backgrounds. Now this tile concept, you assume tile is going to repeat, right? So that's a good approach to take. And it shows you the different types. Scroll, fixed. This talks about the background sizes. The original image may be whatever particular size, and then you can change the background size of it. So this right here is 200 by 300, and then you resize this and resize this. Sometimes when you resize it, though, it's resized to fill the background, but part of the image is cropped. Does Facebook handle this correctly in images in terms of what appears at the top? I can't think of the name of it. The background. So. It doesn't give you a whole lot of options, does it? Yeah. Have you gone some of those pages and the people that put in that background image will put like a huge image, but then it'll only grab like the top or bottom. I forget what it does exactly. I don't use Facebook. Have they changed that where you can do more with it? Can you like shrink it down so you can see the entire piece? Just crop it as it. It's that's what the CSS gives you a lot more flexibility in that regard. I don't know. Yeah, I go to people's page and I look at it and it's like you look at the original image, you know what they're trying to achieve, but it just doesn't look right. So again, it takes some thought on how you want to implement that to have the proper look. Should they allow cropping, do you think? It's nice. It's a nice feature, but since most people don't really understand what they're doing, their background doesn't look good. Or a lot of my friends don't. Multiple backgrounds, borders, border design. Like I said, there's tons you can do. You can create rounded corners. You can have your rounded corners go in further or out further. You can put on a border image on a graphic. stretch, repeat. Slices are stretched to fill each slide or each side. The slices are tiled to fill each side. We can look at it after class. If I tried to bring it up, I'd probably show grades. Um, definitely a no-no. Or if you have it accessible, if you email it to me, I can. I might not have time, but I'll look at it after class because I don't have a meeting till 1 o'clock, so I got 2 hours to kill between that and that meeting. So, no, the state of Kansas is interested in open resources like free textbooks. They want to encourage colleges to be using that more and more because textbooks are killing students. And if I can find an open resource or Creative Commons open resource textbook for the history of computers, then I can find there's free books out there for JavaScript, ones for CSS, HTML. You could go to W3 School and get about everything you'd need in those topics, actually. One thing I don't have is that history and everything that invitation to computer science gives you. Let's see, text shadows. There's a box shadow. MDN. Oh, no, I haven't heard of them. MDN. Mozilla. They're a well trusted site. Yeah, that's what I say. There's enough free information out there. You shouldn't have to be buying. If I can find and I found a potential. I just haven't had time to this weekend. I want to look into it. There's a book, boom, boom. If you're looking for expanding your knowledge in certain areas, and I haven't went and created a free account yet, but Book Boon. If I go to IT and programming, and not all of these are free out here, but for example, if I wanted to automation and robotics, this is a free ebook for students. Download free ebooks as PDF or read online. And the what? No, no, it's not. The majority of what I was looking at, but then again, I probably looked at only 5, was free. That's 127 pages, so it isn't a really huge book on that one. My wife could probably use that to deal with me. Java data structures and algorithms, 253 pages. So again, and it says free access, and you can download the PDF for free. So I haven't went out and looked here, but my hopes is to take more and more of the computer science courses here at Cali to where there's free resources like this, so you don't have to buy books. If they show a color gradient picture. I'll show the color gradient. Just so you see what in the world a gradient is, besides me trying to describe it. That's the color gradient light right there. Goes from dark red to white. And there's radial too. Which one's radial? It goes out in kind of a circular pattern. If you start in the middle and go out, you get that. So anyway, they didn't have a picture of it in the PowerPoint, but that's what a gradient is. And we talked about the opacity. It's where you kind of make it so you can see through it, or it's lighter. You can transform them, rotate, scale, translate. Some of these we're going to come back to when we're looking at it in terms of JavaScript, because you combine items together. You combine some of these elements here with JavaScript, and you can have some really cool effects. Perspective can be thought of in terms of a pair of railroad tracks appear to converge at a point known as the vanishing point. So when you look off in the distance, it looks like 3D type of deal. That's probably about all I wanted to mention. Oh, right, image maps. This is kind of a nice feature if you're going to do web design. How about a computer, like in a computer repair? If you're trying to create a page for that, how would image map help you there? Each individual step by clicking on the parts in the computer. Yeah. So you'd say either click on the part that you want to view. And so you click the hard drive, it goes to the hard drive page. You click on the power supply, it goes to the power supply page, and so forth. I'm not sure if they use any image maps. Some of you may be taking the A+ Essentials class, but they have a lot of labs where they have to pick out different components, and you can do that with image maps. They probably do it with a different technology, but the hotspots can be linked to different URLs through information given an image map. Or an URL, although we haven't covered it yet, an URL can actually refer to your hyperlink can go to later down in the page. So it could be down at the bottom. Have you ever go to one of those pages where you click at the top and it takes you down to the very bottom? It's becoming popular. I hate them. It's like everything's in one big page. And then up the top here, if you click this menu, then it goes down 5 pages. It's still on the same web page. It's just gone down 5. Let's see. Image map defined, client side, image map defined within web page, handled entirely by web browser, server side. Image map relies on a program running on a web server to create and administer the map. If I put a map of the United States in a web page with links to other web pages there, and I put it up on my website, you bring it up at home, which type do you think it is? You would think server side. That will. What was? I think somebody said the right answer. Client. Why is it client? Well, when you go to view all that, it brings it down into your computer. So it brings down the web page, brings down image and so forth. So it's on your local PC. And so you got your own individual map there when you're clicking on it. Your web browser determines it. Now, server side relies on a program running a web server to create and administer the map. This is more of a dynamic type of deal. How about Google Maps? What type do you think that is? The server side. It's all maintained on the server side, and when you click on it there, it's all controlled there. It's not downloading that entire map to your PC. So like when I brought up the U.S. map, and I click, go to images. So where's this? Now it's pointing out here. I'll give you that. But where's this image at right now? No, copied it to my computer. You ever hear of they talk about clearing your browser history, but there's also a bunch of files that it downloads. Why does it download it to your PC? Do you think? Quicker access. Yeah, they got different. It's like caching type of deal. So when I go to like Cali's website, I go there fairly often. Um, it will keep this on my local PC. It could be my internet provider caches the pages, so it will cache it there. So instead of it having to go out to wherever this is hosted at, it sees this website address and says, "Hey, do I got a current copy of this?" And then it'll look. Now I don't know if this will be on here or not. Probably can't find one example of that. If that W3 school has something on it. No, maybe not. On web pages, you can put an expires on there so that will refresh the page. In theory, when you go to cali.edu, it goes out to the original source and says, "Hey, has this changed?" And if it hasn't changed, if it's cached on your local PC or if it's cached on your internet provider, it'll bring in that copy because it's faster. Sometimes you put the expires on there to force a refresh of your page. Probably not so important anymore. This used to be important because if I made a change on the website over here, what do I want it to appear on all my customers' computers? The new website, the change, right? And so if they got this old page cached, and I'm over here, I got my new one, they're looking at my old page, right? So, and again, it's supposed to be smart enough, and like I say, it's probably not an issue anymore because the technology is advanced. It didn't used to always refresh, so it wouldn't see my change over here. So I put the change out there, and I call the customer and say, "Okay, the link is out there now for that PDF that you need to download." And I said, "Say, well, I can't see it." And then I'd tell them there used to be a way you could force it to go out there and get a new copy. First, I'm blind. Oh, was it up there? Oh, oh no. So to force a refresh, you hold down your control and then click the reload button, or hold down. This is in Google Chrome, or hold down control and press F5. Um, so again, if you got that cached on your PC, if you got that cached on the internet provider, this forces it to go out to the original source and get it. Unless you do a lot with web pages, you probably don't have that occur very much, but it is a feature there. When you got server side, there is no need to refresh because it's sitting there on the server. So when you go to Google Maps, it's running 100% out there. Now it's not using image maps for Google Maps, but it shows you an idea of the server side. Let's see. It shows you how to do it. It's kind of pain. You have to define your coordinates. So if they within these coordinates here, then it'll bring up this web page. I don't think I've ever created one of those by hand. There's always utilities. There's programs to create image maps for you. Utilities to create. There's probably an online one too. Free online image map generator. Assuming this isn't a virus. Someday I'm going to get bit real bad. Load image from a website. Okay. Alley.edu. Who doesn't want the actual image? What's the actual image? United States map. Copy link address. Copy image address. There we go. Okay, so I got that in here. You see, you can create a rectangle. Link http alley.edu. I wonder how I draw. Maybe I have to do an add new area. There a dot? Ah. But that's if they get some instructions. Maybe if I read. Creating these shapes is easy as pointing and clicking on your image. Don't forget to enter a link, title, okay. Then once done, okay, so I got rectangle here. Go put that up around Wyoming. Do I click again? Ah, click again. Helps to actually read. That's not letting me click again. Oh, you have to grab that and draw that. So again, it's allowing me to draw a rectangle around it, like that. And then if I choose a different one, like at this one, I chose to be a poly. Got my circle here, and I want to draw it around Texas. This is why nobody would create this by hand. It'd take you forever. Well, I didn't do a very good job there. So how in the world do I? If I can right click on it. Okay, right click gets rid of it. I don't know. I think I've. Oh well, obviously I don't know how to do it, but you get the idea. If you if you knew what you were doing on that, then you come down here and I'm gonna delete that one. If I show me the code, it presumably shows me this, and I edit copy this. That'll be poor if it doesn't let me. Yeah, there it goes. Yeah, isn't it cold in here? You edit copy that, you paste that over into your HTML, and that's how you can do an image map. CSS provides more flexibility with that. And so I'm assuming CSS. I think this just looks like HTML that they're putting in here. Yeah. Anyway, we're done with that tutorial. So that's a good place for a 10-minute break. Let me save this recording. Hopefully it doesn't crash.